Welcome to Math with Mr. J. In this video, I'm going to go through a mini course on integers. We will start with what integers are, then move to comparing and ordering integers, and end with adding, subtracting, multiplying, and dividing integers. So whether you are new to integers, using this as a review, or whatever the case may be, this will give us a nice overview of working with integers. So let's begin by taking a look at what integers are. Now, simply put, integers are numbers with no fractional or decimal part. Integers include positive numbers, negative numbers, and zero. Let's go through some examples to better understand this. Starting with number 1, where we have a number line. We're going to start at 0, which again is an integer. To the right of 0, we are counting up by 1. We are increasing in value. So 1, 2, 3, 4, 5, so on and so forth. And those numbers continue on forever. They are infinite. Those are all of our positive integers. To the left of 0, we are counting down by 1. We're decreasing in value. So -1, -2, -3, -4, -5, so on and so forth. Those numbers continue on forever as well. They are infinite. Those are our negative integers. Going back to 0, 0 separates the positives and negatives. 0 itself is not positive or negative. Moving on to number 2, we have the integers written as a set. So we have the integers listed between those braces. So this is just a different way to look at integers other than that number line above. We can see 0 right here with the positive integers to the right, and those 3 dots tell us that those continue on. And then the negative integers are to the left of 0, with again those 3 dots showing us that those continue on as well. So really, integers are just all of the numbers counting up by 1 from 0. Those are the positives. And then all of the numbers counting down by 1 from 0. Those are the negatives. And then 0 as well. Let's move on to number 3 and write out a few more examples of integers. Let's start with positive integers. Some examples include 8, 37, and 194. Now let's write out a few examples of negative integers. -9, -15, and -72. And then lastly, we know 0 is an integer and 0 is just 0. Moving on to number 4, let's write out some examples of numbers that aren't integers. So for example, 1/2 is not an integer. 4 3/8 is not an integer. 6 3/10, 6.3 is not an integer, and 45 hundredths, 0.45 is not an integer. And we can see that all of those examples include a fractional or decimal part. Lastly, for number 5, let's mark yes or no if the number is an integer. So we will start with A, 42. So is 42 an integer? Yes. Next, for B, we have -18 and 5/10, -18.5. We have a decimal part involved here, so no, this is not an integer. Next, for C, we have 3 1/3. So there's a fractional part here, so no, this is not an integer. Next, for D, we have 0, which 0 is an integer. Moving over to E, we have -7. Is -7 an integer? Yes. Moving on to F, we have -11/12. So is this an integer? No, we have a fractional part here. Next, for G, we have 996. Is this an integer? Yes. And then lastly, h, we have 10 and 75 hundredths, 10.75. Is this an integer? No, there's a decimal part here. So there's what integers are. Let's move on to comparing and ordering. Now let's take a look at comparing and ordering integers. We will start with comparing and then move on to ordering. For comparing, we will go through 3 examples where we will use a number line to help us compare, and then we will move on to 3 more examples where we will not use a number line. Now, when comparing integers, it can be helpful to visualize the integers on a number line. Just remember, the further right on a number line, the greater the value. Numbers increase in value as we go right on a number line. On the other hand, the further left, the smaller the value. Numbers decrease in value as we go left on a number line. Let's jump into number 1, where we have -1 is greater than, less than, or equal to -2. Well, let's take a look at the number line. -1 is right here, and -2 is right here. So looking at that number line, which integer is further to the right? That means it's going to be greater in value. -1 is further right. -1 is greater than -2. So let's fill in our comparison here. And remember, we want the comparison symbol opening up towards the greater value. So like this. And we can read this comparison from left to right as -1 is greater than -2. Now, before we move on to number 2, I do want to mention a couple of things here. When we compare 2 negatives, the one closer to 0 is going to be greater. The one closer to 0 is further to the right. So that's just a slightly different way of thinking about it when we have 2 negatives. And another thing I like to do when comparing integers is relate it to temperature, and that can help us think through these. For example, is -1 degree, Fahrenheit or Celsius here, it doesn't matter the unit, is that warmer or colder than -2 degrees? -1 is warmer by 1 degree. It's a higher temperature than -2 degrees. So -1 is greater. So there are different ways to think through these. Use what works best for you. Moving on to number 2, we have -5 is greater than, less than, or equal to 3. Let's take a look at the number line. 3 is right here, and -5 is right here. So which of those is further to the right? Well, 3. 3 is greater than -5. So reading this comparison from left to right, -5 is less than 3. Now with number 2, we have a negative and a positive. Keep in mind, whenever we have a negative and a positive, the positive is always going to be greater than the negative. And relating this to temperature, which is going to be warmer, which is going to be the greater temperature, -5 degrees or 3 degrees. 3 degrees. Moving on to number 3, we have 0 is greater than, less than, or equal to -4. Let's take a look at the number line. 0 is right here, and -4 is right here. 0 is further to the right on the number line, therefore it's greater than -4. So reading this from left to right, 0 is greater than -4. And to go off of this, whenever we have 0 and a negative, 0 is always going to be greater than a negative. Let's move on to number 4, where we have -95 is greater than, less than, or equal to 6. Well, we have a negative and a positive here. The positive is automatically greater than the negative. And thinking in terms of a number line, 6 is going to be further to the right than -95. So reading this from left to right, -95 is less than 6. Taking a look at number 5 now, we have -14 is greater than, less than, or equal to -11. So we have two negatives here. Which one is closer to 0? Which one is further to the right on a number line? Or if we're thinking temperature, which is the warmer temperature? However we want to think about it, -11 is greater. So reading this from left to right, -14 is less than -11. Lastly, taking a look at number 6, we have -27 is greater than, less than, or equal to -29. So we have two negatives again here. So which one is closer to 0? Which one is further to the right on a number line? That's going to be -27. -27 is greater. So reading this from left to right, -27 is greater than -29. So there's how to compare integers. Let's move on to ordering integers. Now let's take a look at ordering integers. We will go through two examples where we will use a number line to help us out, and then we will move on to two more examples where we will not use a number line. Let's jump into number 1, where we need to order these integers from least to greatest. We'll start by marking them on the number line. 0 is first, which is right here. Then we have -2. Then -1, then 4, and lastly, -5. So again, we want least to greatest here. And remember, the further left, the smaller the value. The further right, the greater the value. So the integer furthest to the left will be our least, which we need to start with. That's going to be -5. So let's start with -5, and now we can go from there. All we need to do is work our way right. We increase in value as we go right, so we're working our way from least to greatest. So next is going to be -2, then -1, then 0, and then lastly, the greatest, 4. And now we are in order from least to greatest. We're done. So -5, -2, -1, 0, and 4. Now before moving on to number 2, I do want to mention, just like when we compare integers, I like to relate this to temperature to help us think through these. -5 degrees is the coldest temperature here, and we work our way up to the warmest temperature, 4 degrees. So just a different way to think through these. Let's move on to number 2, where we need to order these integers from greatest to least. Let's put these on the number line, starting with 3. So 3 is right here. Next is -3. Then we have 5, then 1, and then lastly, -2. Now we need to go from greatest to least. So we need to start with the integer furthest to the right on the number line. That's 5. So we will start with 5, and we need to work our way left now. We decrease in value as we move left, so we are going from greatest to least. Next is 3. Then we have 1, then -2, and then lastly, the least here, -3. And now we are in order from greatest to least. 5, 3, 1, -2, and -3. Let's move on to numbers 3 and 4. Taking a look at numbers 3 and 4, let's jump into number 3 here first, where we need to order these from least to greatest. So we need to start with the least. So which of these is the furthest to the left on a number line? Or think which of these is the lowest or coldest temperature? However we think about it, that's going to be -19. That's the furthest to the left on the number line. So our least, -19, so we will start there. And I'm actually going to cross -19 off in our original list in order to help us stay organized and focus on what's left. Now, looking at what's left, well, we need to work our way to the greatest. So, what's the next lowest in value? We have -10, 20, 6, and -11. So, try to picture a number line here, and we are working our way right from -19. -11 is next. So, -11. And I'll cross that off. And now we have -10, 20, and 6. So -10 is next. And now we are down to the last two, 20 and 6. Well, 6 is next, and 20 is the greatest. So 6, and then 20. So we have all of our integers there, and we are in order from least to greatest. -19, -11, -10, 6, and 20. Lastly, let's move on to number 4, where we need to order these from greatest to least. So let's start with the greatest. So which of these is furthest to the right on a number line? We have -8, 17, -18, 10, -7, and -12. The greatest is 17. Let's start there. So 17, and cross that off. So looking at what we have left, -8, -18, 10, -7, and -12. 10 is going to come next. That's actually the only positive number left, so that's going to be after 17 here. Now we have -8, -18, -7, and -12. So we are working our way left on a number line. So next is -7. And now we are down to 3, -8, -18, and -12. Next is -8. And we are down to 2 here, -18 and -12. -12 is next. That will bring us to our last integer here, the least, -18. And now we are in order from greatest to least. 17, 10, -7, -8, -12, and -18. So there's how to compare and order integers. Let's move on to adding, subtracting, multiplying, and dividing integers. Now let's take a look at adding, subtracting, multiplying, and dividing integers. We will go through 2 examples for each. We'll start with adding integers. And when it comes to adding integers, there are a couple of different ways to think through these, so I'll show you 2 ways to go through each of our examples here. Let's jump into number 1, where we have 12 plus -7. We'll start this problem by taking a look at the signs. We have a +12 and a -7, so we have different signs, a positive and a negative. Since we have different signs, we are going to take the greater absolute value and subtract the lesser. Our answer will take the sign of the greater absolute value. Let's start by writing the absolute value of both 12 and -7. And remember, absolute value is the distance a number is from 0. The absolute value of 12 is 12. The absolute value of -7 is 7. Now we take the greater absolute value and subtract the lesser. These are already in order, so we can subtract. If the larger absolute value comes second, you can always switch the order to find the difference if need be. Let's subtract. So 12 minus 7 is 5. Now we need to determine if our answer is going to be positive or negative. So we need to take a look at the larger absolute value, which is this 12. So we take the sign of the larger absolute value from the original problem. So the larger absolute value is 12. Let's take a look at the 12 in the original problem, and that 12 is positive. That means our answer is going to be positive. So our final answer, a positive 5. So a quick recap here. Basically, we forgot about any negatives because we were working with absolute values. We then found the difference between the absolute values, and the answer takes the sign of the greater absolute value from the original problem. Now let's think through this another way. And this way is going to be more of a mental math approach, just basically thinking about what's going on in this problem. So let me rewrite 12 plus -7 here. So our original problem. So we are starting at a positive 12, and we are adding a -7. By adding that -7, we are decreasing in value by 7 from that 12. We can basically think of this as 12 minus 7, or 12 take away 7. That gives us our answer of 5. So 12 plus -7, we are decreasing that 12 by a value of 7, so we get a positive 5. So again, we started at a positive 12. Always think about where you are starting and where you are going from that starting point. So we are adding a -7, which is decreasing our 12 in value by 7, and we end up with 5. Let's move on to number 2, where we have -8 plus -10. Here we have two negatives, so the same signs. So we're going to add the absolute values and use the same sign. So let's start by taking a look at the absolute value of -8 and -10. The absolute value of -8 is 8, plus the absolute value of -10, which is 10. Now we add those absolute values because, again, we had the same signs. 8 plus 10 is 18. We used the same sign from the original problem, which those are negatives there, so our answer is negative. Final answer, -18. Now, if we were to think through this, we can think that we are starting at -8. So let me rewrite here. -8 plus -10. So again, starting at -8, and we are adding a -10. So that means we are decreasing in value by 10. That leaves us at -18. Like I mentioned earlier, think about your starting point, so the number you are starting with. We have a -8, and then adding that -10 tells us we are decreasing in value and end up at -18. -18 is our final answer. That's how we add integers. Let's move on to subtraction. So here are our examples for subtracting integers. Let's jump into number 1, where we have 5 minus -9. Now, when we subtract integers, we're actually going to add the opposite. So if you're able to add integers, you're going to be able to subtract. The opposite of subtraction is addition. And then we take the opposite of the number we are subtracting. So this gives us an equivalent problem, and we are able to use this strategy. So we have 5, and then let's add the opposite of -9. The opposite of -9 is +9. So 5 plus 9, that gives us 14, a positive 14. And that's our final answer. Now that answer may not make sense at first, but let's think about how we end up with a positive 14 in this subtraction problem. Whenever we subtract a negative, we actually increase in value. I like to think of this in terms of money. A negative represents a debt or an expense when it comes to money. So that -9 would be a $9 debt or expense. Think of subtracting a negative like subtracting or taking away that debt or expense and getting that money back. That is a good, positive thing and increases the value of that problem. So, something to think about. Let's move on to number 2, where we have -3 minus 20. So, let's add the opposite. -3 plus the opposite of positive 20 is -20. So we have -3 plus -20. Now, adding that -20, we are decreasing in value by 20. So we're starting at -3 and then decreasing in value by 20. That's going to give us -23. And that's our final answer. That's how we subtract integers. Let's move on to multiplication. Here are our examples for multiplying integers. Let's jump into number 1, where we have -7 times +4. We have a negative times a positive, so we are working with different signs. Now, when we're working with different signs, this tells us our product, the answer to a multiplication problem, will be negative. So -7 times 4. Well, 7 times 4 is 28. And then we know this product is negative because we are working with different signs. So this is -28. And that's our final answer. To recap, different signs equal a negative product. So if we have a negative times a positive, that will equal a negative product. Or if we have a positive times a negative, that will equal a negative product. Let's move on to number 2, where we have -10 times -6. So we have the same signs there. We have 2 negative numbers. So our product will be positive. So let's think. 10 times 6 is 60, and we have the same signs there. So this is going to be a positive 60. Our final answer, 60. So to recap, same signs equals a positive product. So negative times a negative equals a positive product, and then a positive times a positive also equals a positive product. That's how we multiply integers. Let's move on to division. So here are our examples for dividing integers, and you'll notice that our rules are the same for dividing integers as they were for multiplying integers as far as working with those positives and negatives, and if we're working with the same signs or different signs. Let's jump into number 1, where we have -48 divided by -8. For now, let's just think of this as 48 divided by 8. And what that quotient will be. Remember, the quotient is the answer to a division problem. So 48 divided by 8 is 6. So let's write a 6 here. And now we need to determine if our quotient is positive or negative. Well, we had a negative divided by a negative. So anytime we have the same signs in our original problem, our quotient is positive. So same signs, positive quotient. So -48 divided by -8 equals a positive 6. Now let me back up here and further explain same signs. So same signs would be a negative divided by a negative, like number 1, that equals a positive, and then also a positive divided by a positive equals a positive. Let's move on to number 2, where we have 36, a positive 36, divided by -4.
So let's think of this as 36 divided by 4, which is 9. Now we need to determine if that quotient is positive or negative. Well, we have a positive divided by a negative. So we have different signs. Different signs, that is a negative quotient. So negative 9 there. 36 divided by negative 4 equals negative 9. So for different signs, that means a positive divided by a negative, like number 2, that equals a negative, and then a negative divided by a positive equals a negative.
So there you have it. There's a basic overview of working with integers. I hope that helped. Thanks so much for watching. Until next time, peace.